level what it is we're going to be doing. So it's lesson 6. So we're going to look today at how we can add authentication into our little albums library, our little music library that we've been working with. So what things do you think, what are we going to have to do? So right now this is a public page. What things are we going to have to do in order to secure this page so only authorized users can access it? We're going to have to do a number of things today. What are we going to have to do in order to make this happen? Kita? Okay, so we're going to need to have a list in our database of authenticated users. Yep, so we're going to have to set that up because right now all we have is a place to store albums, right? We don't have anything. So yeah, we'll definitely need that. What else are we going to need to do? So we can build a users table in MySQL, which we'll do. Okay, so we're either going to have to add a page where either we can add users or potentially users, if our business would allow it, users can register themselves, right? So they'll create an account and we'll save them to that new table in our database. Yep, so we'll need that.
Make changes to this page so that if the user is not logged on, the edited link button is not shown.
Yeah, so what we'll need to do is modify this page to check every time the page loads. We need to know if the user is logged in or not. Right? Now, there's 2 ways we could do this. The first option is we could say, well, you can't even see this page. This whole website is private, and you can't even see our album list unless you're logged in. That's one option. The other option, as Makita said, is we could still show this page, but we can decide whether to give the users access to our links. We could hide the add link and we could hide those columns potentially. So this page is still public, but parts of it would be private. We could do it either way.
If we hide the whole site, can we make it so some users can edit and delete, some can't?
We could, yeah. So then not only do we need a list of users, but we need to have different roles or permissions as well, right? So primarily we're going to talk about authentication, which really has to do with identifying who the user is. The next level of that is what you're talking about, Ryan, which is called authorization. So once we know who a user is, what are we going to allow them to do within the application? So we may or may not, we probably won't have time to get into that. But yes, we certainly could potentially do that, right? And Blackboard is an example of that, right? We're all authenticated users when we log into Blackboard. We all have valid credentials, but we have different levels of authorization. The features and functions that are available to you, the things you see, well, those are more limited than what I can see. And then there's levels above me, people who are like the administrators of Blackboard can do things like create new courses, delete logins and things like that, which I don't have the ability to do as an instructor. So that's a pretty good summary of what we're going to need to do. We're going to need to build a table in the database. There's one other thing we missed. So we said we'll need a table in the database. We'll need a way to create users. We'll need an authentication check on this page to either hide it entirely or hide certain parts of it. There's one other piece that's missing though. So we have a users table, we have a registration page, and we have a security check here. But there's one other thing we're going to have to build. How are users going to authenticate themselves? Right? We're going to build a registration page for a user to sign up. That will create a user account in the database. But if we come back to this website tomorrow and we want to have access to all of the features, how do we tell the website, hey, I already registered for this site, so I don't have to register again? Right, we're going to have to build a login page. So we have some way for a user to give us a credential, and then we can check it in our MySQL database and see if that credential is valid or not. Now, our register and our login pages, these are going to be basic HTML forms. So to save time, I've already built them and I've put them on GitHub and we'll just download them. We won't spend our time in class today creating HTML forms. You guys have created enough of them now that I know everyone knows how to create a form. Okay, so we won't hand code that. We'll just take my files and bring them into our project. So visually, what we're going to do is going to look something like this. Here's what we want. More lovely, rich artwork for you. Okay. So somebody wants to see the albums page, right? So they either click a link or they type the address of our albums page. And our web server says, yes, we have that page. So I'm going to send the page back. So at the top of the page, as Makita said, this is where we need a check. Do we know who this user is, yes or no? Now, if they've already authenticated themselves, then we can show them the content, and that would include our add, edit, and delete links. If the user's not authenticated, well, we have two choices. One is we could show them the page anyway, but without those links. Our other option, like Blackboard, right? So let me grab this URL from Blackboard. I'm logged in here in Firefox. I'll open up Chrome. What's going to happen when I hit enter? Right? So there's obviously a check on the top of every page in Blackboard that's checking, is this user authenticated, yes or no? So if not, right, Blackboard just redirected, it kicked me over to the login page and makes me identify myself. So I'm going to enter a username and password. If my username and password is no good, it checks, it keeps me here, but it gives me a message. Usually it's going to be in red. It gives me a chance to log in again. And if I put a valid login in, it'll then redirect me, but it's going to do something first. And we need to talk about this because this is the most important part of one of the two most important parts of the whole authentication process. After it checks my login, it has to store my identity somehow. Why do we need to store my identity when our users log in? Why don't we just say, okay, we found your username, we found your password, you're good. No problem, and then you can just carry on. Raj?
Two users can have the same username and password. So it's better to give an ID.
Okay. Yeah, that's one reason.
I think the story the user ID is that, so you log in once, but every time you refresh the page to move to another page, it's going to ask you to log in again. So that you store that the user won't have to log in again for a certain period of time. Exactly.
Okay. Here's going to be a question I'm going to ask you next week. I'm telling you this right now. This is a question on the midterm. Okay. The internet and HTTP is, and if you're not in class, you're not seeing this on the chalkboard. HTTP is a stateless protocol. What does that mean? I mean, you gave the example of it. Why do we say it's stateless? So I log in here, right? On this page or on my validation, my check login page, it knows who I am. Why do we have to store the ID? What does this mean that it's stateless?
We can open this page anywhere in the world or something?
Good guess. Well, let's think about it this way. If we create a variable, let's say we have 3 PHP pages, okay? Page 1, page 2, page 3. If we create a variable on page 1 and we give it a value, what happens to that variable when the user goes to page 2? So let's say we create a variable called username, right? And we give it a value of Caitlin, right? What happens? So on page 1, the username is Caitlin. What happens when the user goes to page 2? What's the value of that username variable? Will that value still have, will that variable still have the value of Caitlin, or will it be empty? Yeah, it's empty because HTTP is stateless. So any variables, any values we have on one page are gone as soon as the user goes to another page. So unless we post them from one page to the other forever. So why, if we come back here for a minute, why is it important when a user logs in? We validated their username and password, and as Raj said, we want to store their ID. So why do we want to store it? What happens if we don't store their ID? So Brinder?
So when we go from one page to another, we don't have to log in again?
Right, because otherwise on every page, it's going to keep telling you to log in. Your ID doesn't stay with you. Okay. So we need some way of, when someone logs in, we need some way of storing their identity for that visit to the website so they can move around and we know who they are from one page to the next. It won't happen automatically because HTTP is stateless. So the state of a variable doesn't persist, it doesn't last. So we have two ways we can store their identity. I've explained one of them here, and this is the method we're going to use. What would be our other option besides a session where we could store data about that user and they could go to different pages and we won't lose that information? Cookies would be the other option. So we can use cookies, we can use sessions, or we could use a combination. Some websites, and we'll look at them, will use both. Okay, so we'll talk a bit more about sessions and cookies. But if we don't do this step, we let them log in, as soon as they go to another page, they're just gonna, our user's gonna get asked to log in all over again, which is a really good way to annoy your users, to make them keep logging in all the time. Okay. So this is kind of like the equivalent of getting your passport stamped when you enter a new country. By having the stamp in your passport, you don't have to go and get that passport stamped every day, right? You're allowed to be here for that period of time. So that's in effect what we're doing here. We're approving the user once, so on every single page we can check if they're identified or they're anonymous. So once we store who they are, now the user can go back, they can ask for the albums page and we can show it to them because we've stored who they are. Okay, so this is all the stuff that we're gonna do visually. So just before we do, I'm gonna give you about 5 minutes and we'll kind of make a list together as a class. I want you to do a little research online, use your Google Foo, and I want you to compare sessions and cookies, right? Because we said we could use either or both for storing user identities. So do some research. What's the difference between a session and a cookie? And why I'm going to suggest we're going to use we use sessions in this class. So I want you to find out why it might make more sense to use sessions than cookies. So we'll compile a list together in 5 minutes. See what you can find out. I'll make a little spreadsheet here with 2 columns, sessions and cookies, and then I'll post it on Blackboard when we're done.
Are we moving away from cookies now?
Well, you do some research and we'll talk about it. You don't need to make this list. I'll make the list and I'll post it on Blackboard. You need to do some research as to what things are going to go in our list.
Can I speak with you for a minute?
Well, I need to encourage it, so garbage all the time. So I want someone to do it.
Give you one more minute to do your reading. All right, I'll pause you here. Should be enough time. So what'd you learn? Michael?
Sessions are undoubtedly better than cookies for use in this sort of scenario. Because sessions store all the sensitive information on the server instead of on the client. If it was stored on the client, you could have some pretty dangerous problems where they manipulate the cookies data and send take requests or bad requests to hack up your server.
Okay, Ryan?
It sounds like it's more work to use cookies because this guy was saying how we had to put some information on a database to authenticate the cookie and make sure it wasn't manipulated.
Okay. Okay. What else should we put on our list, Caitlin?
Sessions can be as big as you want them to be, but most browsers put a limit as to how big cookies can be.
Okay. Okay.
The expiry date of cookies can be set by the provider, but expiry dates in sessions is usually the default 24 minutes set by PHP.
Okay. So typically, and that depends also on the type of web server. If you're using a Microsoft web server like IIS, like we're using on Azure, usually the default timeout for a session is 20 minutes. Now, we can extend that, okay? And there are times when we want to extend that. I've learned this the hard way. I once built an application for a client, and I built them a really long form. Like there had to be like 100 inputs on the form. There were all kinds of calculations. And when my clients started using it, I started getting angry phone calls saying, I just spent 3 hours filling out the form, and then I hit save, and I got kicked to the login screen because my session timed out. So we actually had to put a timer in the header that shows them counting, shows it counting down and warns them, and we put save buttons all the way through the form to prevent that. Okay, so we can extend this in a particular site. Krupa, you had your hand up. Something else you want to add? Okay.
These are stored on local.
Okay.
You have more control over sessions than you do with cookies on, like, I guess, settings.
Okay.
Cookies seem to be better on lightweight servers because they don't require as much extra, like back-end storage stuff.
Okay. That is true. And that is something to be mindful of. We can store things in the session, but it does take up memory on the server. So if we're storing a lot of data in the session with a lot of users, that can eventually start to affect the server performance. So we probably want to use the session, but we need to use it wisely and not store stuff in the session unless we really need to. Anything else we could add about session and cookies? What else can users do with cookies that they can't do with sessions? Right. So these are accessible
Can be deleted.
by the users, right? Which could include, so if we rely on cookies only, any user who deletes for authentication, any user who deletes the cookies, or they can block cookies, then they're not going to ever be able to log into our site if cookies is the only option. Yeah, so it's less secure. So many sites still do use, there is one big advantage to cookies. What's the big advantage to cookies in terms of logging in that sessions don't offer?
I mean, the cookie can be saved over a long period of time, so you can save your login information in repeated ways.
There's no way to do this with the session. Okay. Now we can actually tell when we go to a website, we can actually tell whether they're using, sometimes we can tell whether they're using sessions or cookies.
What's it right there?
Oh, they actually got rid of this. That's interesting. Anybody notice the change here? They used to have a checkbox here that said, keep me logged in. That checkbox is gone. You see it on yours? What browser are you in? That's interesting. Let me try it here.
Maybe it's maybe the keep me logged in function is like constrained to secure connections. This is an open connection we're on.
Well, I'm just going to log out. So I'm logged in here. Let's see. Let's log out. Good Lord, just give me a login button already. Thank you.
Is that Java loading when it does that?
No, it's not. If we see an option that says keep me logged in, then we know they're using a cookie, right? Because that allows us to close the browser, turn the machine off, come back to it another day, and we're still logged in. So when we see that, then obviously they're using a cookie, right? The session will not persist. As soon as you close your browser, your session's gone. So if you're logged into Blackboard, if I actually log in here, what's going on with the internet connection? If it ever allows me in, if I close my browser and open it back up, I'm going to have to log in again. So the cookie is a way of preventing that. So I'll grab that URL, close Chrome, reopen Chrome, try and go back there. I just logged in. I never logged out. I just closed my browser. I really love the Chrome login screen coming up. Right? As soon as I close that browser and reopen, my session's gone. So that storage of my identity, it's been lost. So as a user, how many of you stay logged into sites like your email or your social media so you don't have to log in every time you use them? This is a terrible idea. If it's secure, if it requires enough security to make you log in, you should log in every time you use it, right? Because all someone has to do, especially now that so many of our devices are portable, they're not desktop computers that stay in our house. Well, all someone has to do is grab your device and they're logged in as you to everything that you let them set a cookie for and keep you logged in. You should be logging into your email and your social media accounts every time you use them. Because it's just not that secure. It's convenient, but think about the consequences of letting somebody got your device. Think about all of the accounts of yours you've given them access to now. Same, you notice on some banking websites, it'll never offer to remember your login, but it will offer to remember your bank card number. So you don't have to type it in, right? Well, how does it do that? It encrypts it and writes it to a cookie. But that way, if someone gets your device, well, they're already halfway to getting into your account because you've given them one of those two important pieces of information. So learn your bank card number. Don't use a cookie to write it into your browser. It's not safe. Okay. Anything else we should add here? So cookies are more convenient for users, but much more dangerous. Honestly, in all the time I've built applications, which is a long time now, I've never, ever used cookies for login and enabled people to stay logged in. If my customers ask me to do it, I talk them out of it and say, no, you don't want to do that. You want to make sure if your data is important and only authenticated users can come in, every time someone comes, you should be forcing them to log in. And if they don't log out, well, our session is going to time them out eventually. Okay. I'll throw this up. Is there anything else important we should add to this that you read about? Raj?
I have a question. Session typically is expired in 20 to 24 minutes. So can we set that minimum time to like 10 to 15?
Yep, you can change the timeout. You can, if you want it even shorter, you can. We don't typically need to. But the idea here is our session, it refreshes every time the user loads a new page. The session automatically kind of gets refreshed. We don't lose anything we've put in it, but it stays active. So when we say 20 to 24 minutes, it's not 20 to 24 minutes if users are moving around our site. It's 20 minutes from the time they load a page and then they don't do anything. They walk away from the computer. or they're working on that one page. That's how I was timing my users out, because they were filling out the form, but until they submit it, they're not interacting with the server. There's no new request to the server. So if that was more than 20 minutes, it times them out.
Did you write some code that if they're moving the mouse around the browser, it catches that and resets the session?
You can. The problem is that's a client-side event, and the sessions are stored on the server. So you'd have to do a fair bit of work to make that happen. Okay.
Would you have to use a cookie to make that work?
No, you'd have to use something like Ajax that could interpret or jQuery that could interpret a client-side event and then make a request to the server without loading the page, or Angular. You'd need JavaScript to do it. Okay, I'll just upload this file here so you guys have access to it. So for the reasons we've talked about, we're going to use sessions just because they are more secure. Our users can't access them. They can't manipulate them. So I'll just post our little spreadsheet here. So there'll probably be some questions on the midterm related to some of these features. Okay. All right. So there's now a file on Blackboard. If you can open it up. There's a file here that says Lesson 6 in-class notes. It's a little Word document with a few different activities in it. If you can open it up, please. Exercise 1 is the world's easiest matching exercise. There's some new code here that we haven't seen before. Whoops. Hang on, that's not the current version. Just a minute. Close the file, sorry. Give me 1 second, I want to re-upload it. My apologies. What? Blackboard is not my friend today. Sorry, it didn't upload my file. I better try it again. Just delete this entirely and try it again. Okay, this is like my 5th attempt to get this file on Blackboard properly. Okay. We have a winner. So if you refresh your Lesson 6 folder, it's right here underneath our sessions and cookies discussion. So here's the world's easiest matching quiz. You get 3 pieces of code on the left and 3 definitions on the right. Match the code with the explanation of what it does.
The correct answers are 1.
Okay, well, hang on. Don't tell me. Let's give everybody a chance to actually look at it before you tell us all the answers.
Shouldn't it be C instead of F? I mean, there's only 3 columns.
Yeah, that should be.
I mean, 3 rows.
Yes, so that can be C instead of F. So Brad, just wait another minute and then I'll ask you to share your answers with us, okay? Okay, Brad, did you want to share what your thoughts?
Okay, so basically 1B, 2A, 3C. 2A was easy because they both used hash and mentioned the password. Fetch column would be B because it's a single filter used to select only one records for the database table. And where username and password would be C because the PDO function to select a single value from a database.
Okay, now your answer for one is right. Sorry, so password hash. Hash is a password, and we'll talk about hashing a bit more in a minute. But our other two, so 2 is A. What about fetch column? What does it do? I won? Yeah, it's C. This is a function, so we've used fetch to get a list of records. Sorry, we used fetch all to get a list of records. We use fetch to get a single record. Fetch column gets a single value. So when we only want one value, so fetch column is C. So the where username equals username, that's obviously our SQL filter. We're going to put in our select clause, our select command, when we're trying to validate a user's credential, trying to verify their credentials.
You guys was focused on trying to see if there were hints of meanings that I forgot about that. So apparently the acronym for the correct answers is CAB, C-A-B.
You got it. So let's have a look at this password hash function. So this is a built-in function in PHP. Let's take a look. What is hashing, actually? What does it mean? Hashing is not unique to PHP. It's kind of a generic programming term. We can do hashing in all kinds of languages. We can do it in Java. We can do it in C#. We can do it in PHP. What does hashing mean?
A hash is an encrypted string. We can use a hash code to represent the input to a function that puts in the string design.
Okay, so it's a kind of encryption. It's like encryption, right? So it will take a plain text like the word password, and it'll turn into something like ABC123, a whole bunch of kind of seemingly random letters and numbers. So the user can't actually read the value. There's one really important difference, though, between hashing and encryption. They're similar, but there's something really important that's different that I will definitely ask you about next week. What's the difference between hashing and encryption? And why are we going to use hashing for our passwords rather than encryption?
Just an idea, like hash is just to not to show the user a password, and encryption is it totally encrypt the data to send to the server.
Good guess. Not quite. Yeah, although we can do the same with hashing. Ernest, what do you think?
Hashing is a one-way process.
Hashing is one way only. Okay, so Here's what we mean by that. We'll just make a new file. So if we hash, let's say our value is ABC123, right? This is the password our user gives us. When we hash it, it's going to turn into something like this. This random. But with hashing, there is no way to unhash. There's no reverse hash function. Encryption is two-way. It will still look something like this, but any value that can be encrypted can be decrypted. So it can be converted back to the original value. So why, for passwords, why are we better off to use hashing instead of encryption?
Well, if somebody like hacks your server and retrieves all the files containing your stored hashes, if they were encryptions, they can decrypt it on their own once they figure out your formula, and then they have all the password data for all these users, which could be repeated across multiple services. It'd be a nightmare.
Think about what happens when you forget your password on a website. What happens? Right, they make you reset. They make you identify yourself some other way, but they always make you reset it. Why? Because they can't show you the old password because all websites hash them. So they have no way to take this is the value that gets stored in the database. So there's no way to show you that that was ABC123 a long time ago. So not only do we use hashing, but we also use, so we've used hashing, but along with hashing, we also use a technique called salting. Does anybody know what salting means?
Adding random chunks of random text to the password, so it's even more intelligent.
Right. See, if we only hash the passwords, that will mean if we all enter the same password, it will all get translated to the same hash value. So even though we can't read it, you know, if we crack Sarbrinder's password, well, now we know Pankaj and Raj because it will all look the same. So salting is where we generate a random set of letters or numbers, and then we use that as part of the hashing. So if we all have the exact same password in plain text, the actual hash value will still be unique to every one of us. So it's an extra layer of protection.
So the server's always reading that value, not the password.
Right. The plain text password, it doesn't exist. It's not stored anywhere.
So as far as the server's concerned, that's the password, not the top.
Yes. So PHP has a function called password hash, which we're going to use. So it takes two parameters. The first one is what is the plain text password, so whatever the user types in our form. And then there's different algorithms for this. Now the default is called password default. So it uses a PHP encryption library, and it says it recommends that we should allow up to 255 characters potentially in our database to store the password. When we use it, it's not going to create passwords that are that long, but they change and update this algorithm often. So their advice is potentially we could be giving you 255 character hashes. So make sure your database is not going to store 50 characters, you're going to store 255 maximum. So we'll do that. So there's another one. So this will use this library called crypt blowfish, and it will always give us 60 characters. But we'll use the password default. And they update that algorithm regularly because once these are in use for a few years, what happens to them? When they have a hashing algorithm that lots of developers use, what's going to happen to it eventually?
Well, somebody's going to figure out how to work.
Right. So then they need to make a new one. So by using the password default, we'll always be using whatever the current version of PHP is doing for hashing, and they will update that periodically. So we're going to use hashing, not encryption, because it is much more secure.
When they update the hashing algorithm, do we have to update our databases and websites?
Well, they're saying as long as you give yourself 255 characters and just use password default as the algorithm, you should be fine.
So we won't have to update anything unless it's a big update on their part.
Right. Right. Because our web server should always have the latest version of PHP. So we should be okay. All right. So we want to hash our password. So if someone looks in our database, they just see this long string of seemingly random letters and numbers that look kind of like that. And there's no simple way to unhash it. They'd really have to go through some kind of advanced hacking techniques in order to do it. So that's kind of what our passwords are going to look like. And you'll see if we create 2 accounts and we use the exact same password, that password hash, when we look in our database, there'll be different values because that includes the salting feature. PHP has just a regular hash function as well that hashes, but it doesn't salt. So if we put in the same value twice, the hash value is the exact same. So this is better. It's more secure.
How is the salting generated and replicated later? Like, how do they know which salting to use for which user?
That's part of the library. You can read about it here. It's in the PHP crypt class if you want to read the details of how they do it. And they probably update that regularly as well.
Okay.
So you can read about it. Okay, so that's kind of our introduction. That's where we're going. Like that's kind of our hour lesson. We haven't written any code, but now I think everybody probably has a decent idea of what it is we're actually going to do to make this all work. So let's take a 10-minute break. When we come back, the first thing we'll do is we'll create a users table in the database. We'll just copy and paste that script and create a users table. And notice I followed their documentation advice and said, let's allow 255 characters, even though right now our hash won't be that long. So we create a table with an ID that's auto-generated, username and password. And then we'll grab the files I created, the forms I put up on GitHub for you, our register and login page. I've even added a little script to make sure we force our users to create strong passwords. They can't put in the password of A. They're gonna have to put in an 8-character password with uppercase, lowercase, and some numbers. And then we'll work on kind of the rest of this stuff. How do we check a login? And then how do we make that page become private so only a logged in user can see it? We should be able to do all this before the end of class today. Okay, let's take 10 minutes. We'll come back at 3:05.